Hello and welcome! In this lecture we're going to implement the concept of action points so that our actions have a certain cost. Alright, so here we already have quite a lot of the game working, except right now there's no limit to our actions, so I can move as many times as I want, I can do as many spins as I want, I can take an infinite amount of actions. Now ideally there should be a limit, so let's add that. Now as to how we add this is actually a game design question. One approach would be to make a global action points pool that would be shared between all of the player's units. So for example, let's say you had 4 action points, so you could either take 4 actions with a single character, or maybe take 1 action with this one, then 3 with this one, or 2, and so on. However, with that approach, it can end up with making a single unit overpowered. Basically allowing a unit to take like 10 actions in a single turn, that can be quite tricky to manage. So how we're going to handle this is actually by making each unit have its own action points. Since we're going to add them to the unit, then let's go into the unit script. And here let's just add a simple int, so a private int, call it action points. And by default, let's put it at 2. Okay, now we need to incorporate this logic into all of our actions. So for that, let's make a function over here on the unit to test if we can spend action points to take a certain action. So let's go all the way down here, and let's make a function, make it public, going to return a boolean, and call it can spend action points to take action. And we're going to receive a parameter of type base action for the action that we want to test. Okay, so here let's test if we have enough points for this action. And here we have another design question. Now, if you want to keep it simple, you can make it so every action, regardless of type, always takes the same amount. So maybe every action always takes just 1 action point. That's one approach. And we're actually going to do pretty much that. However, let's also set up our code in a versatile way so that maybe later on, if we decide that we want to change some action costs for some action, then we can do that. Like I've mentioned previously, my goal with this course isn't just to make this one specific game, but rather to build a nice expandable base, so that after you go through the whole course, you can easily expand upon it with your own actions, units, maps, and so on. So let's make this versatile, and let's go into the base action to define a cost for each action. So let's go into the base action class, so here it is. And over here, let's make another function, going to make it public, going to return an int, and call it the get action points cost. Now for this one, like we saw, we have 2 options. We can either make it abstract, if you want to force all of the actions to implement this, or we can make it virtual and pretty much just define a default cost. So let's go with that approach. So let's make this virtual, then let's add a function body, and in here just return 1. So by default, all actions have a cost of 1, but then we can override it. So for example, let's go into the spin action, and up here let's override that one. So do a public override. Let's override the get action points cost, and for this one, let's say this one takes 2 action points. Okay, that's it. So now we have this nice function on every single action. So let's go back into the unit script. And up here, it's super simple. We just need to test. So test if the action points, so the action points for this unit, if they are bigger or equal to the action points for this action. So let's ask the base action for the get action point cost. If so, then we can indeed take this action. And if not, then we cannot. By the way, yes, here you could just do a return directly on this. So you could just do this, exactly the same thing. So whatever you prefer, let's go with the bigger one just for fun. Alright, so that's it. This should be working. Now this function is just testing if we can spend these action points. And let's make another function to actually spend those action points. So let's make it private. We want to make sure we limit the spending of action points as much as possible. And let's return void and just call it spend action points. And we receive an int for the amount that we want to spend. Then here we'll just decrease it. So go into the action points and decrease it by amount. Now here we could also add some error checking to make sure that action points never go under 0. But instead of doing that, what we're going to do is we're going to make sure that we can only spend action points if we can actually afford them. So let's go into the unit action system. Let's go to this script. Okay, here we are. Now let's go to where we're taking our action. So here on update, handle the selected action. Okay, so here it is. We're just testing if it is valid, then we take the action. Here, if it is a valid grid position, let's ask the unit. So go into the selected unit and ask if this selected unit can spend enough action points to afford this action. So can you afford the selected action? And if so, then we want to spend the points and then take the action. So in order to do this, we can either expose the spend action points, or we can actually just make another interesting function. Let's make a function that will pretty much call both of these. So let's make a public, we're going to return bool, and let's call this try, because it's going to try to do something. Try spend the action points to take a certain action. Receive a base action for the base action. Now in here we just test if the unit can afford the action points. So if we can spend the action points to take this base action. If so, then let's spend the action points. So going to the base action in order to get the action points cost. And this means that we have successfully spent the action points to take this action. So let's return true. And if not, if we can't afford that, then we're simply going to return false. So here return false. Okay, so we've got a function that will pretty much do both the things that we want. So let's go back into the unit action system. And up here, instead of asking if we can spend and telling it to spend, let's just do both at once. So try to spend the action points. And if it does succeed, that means we can afford it. So let's run our action. And by the way, here, if we want, we can also refactor this code a little bit. Just in case you don't like having too much indentation with this many ifs, we can essentially do the opposite. So for example, let's do this if. But instead, let's test for the opposite. So if this is not a valid action grid position, then we return. Then we test if we cannot afford to spend them. If we cannot spend the action points, let's return. If not, if we get down here, then that means all the checks have passed, so we can just run this. So just two ways of doing things depending on how you like to structure your code. Both of them work exactly the same. Alright, so with this, let's test and see if we can spend action for as long as we have action points. Let's see. Okay, so here we are, and the move action has a cost of 1, and the spin action has a cost of 2. So let's try moving 1. And by default, the unit has 2 action points. So if we try moving, okay, we did move. Now the unit should have 1 action points left. So if I try going to the spin, which again has a cost of 2, if I try spinning, and nope, it does not work. However, if I go back into the move, the unit should still have 1 action point remaining. So if I click, yep, there you go, it does move. But now I click again and nope, can't do it. All right, so yep, that logic worked. Now, like we saw, we made this logic on a per unit basis. So now if I select this other unit, this one should still have 2 action points. So I can move once, I can move twice, and nope, no more. All right, great. So each unit has their own action point amount. Okay, everything is looking good. Now let's just add a proper visual so we know how many points each unit has. For that, let's find our canvas. So in the hierarchy, here is our canvas, and let's go into the unit action system UI. So we've got our action buttons, okay? Now here, let's also add a text object. So let's create a new one, new UI, a text object. Let's call this the action points text. And let's put it just slightly above the action button. So let's actually change the anchor. Let's put it on the bottom. Let's push it a bit down. And for the width and height, let's put both these on 0. Then for the text, it's going to say something like action points 2. Let's put it in bold. We're going to lower that a bit, but first on the alignment, put it down center, down the middle. For wrapping, let's disable it. Okay, everything like that. And now let's just play around with the font size. And finally, let's also change the material preset. Let's put it outline just so we have a nice, simple outline. Okay, so just like this looks pretty good. Also, one more thing, remember how we have the action busy on top, except it's currently hidden. So let's unhide this, yep, just to make sure that it does occupy so it doesn't look a bit ugly. So let's select the image over here on the action busy UI, and let's just scale it a bit upwards, just so it matches that one. And actually, let's not scale the image, we made this occupy the parent, so let's scale the parent instead. So just a bit upwards, okay, just like that. And once again, we can hide it to keep things nice and clean. All right, so we have this text element. Now let's write the code for it. So let's open up the unit action system UI. And up here, let's begin by making our reference. So let's make it a serialized field. Let's make it private of type TextMeshPro. So let's actually add TMPro. So using TMPro. And up here, let's define our type. So TextMeshPro, again, we're working in the UI. So let's select the UGUI version. Under this one, call it action points text. Then let's go into the editor, and here let's drag the reference, okay? So now that we have this reference, we really just need to update this with the action points amount. So let's make a function to do that. Let's make it private void, and just call it update action points. Okay, so now we go into this one, and we modify the text to say action points, and then the action points for the active unit. For that, the selected unit, we can go into the unit action system, the static instance, in order to get the selected unit. So this is the unit for the selected unit. And then from the unit, we can ask it for the action points. So let's actually expose them in some way. So up here, let's make a public int, get action points. We just return the action points, okay? So now we can go back into the UI script, and up here we've got the selected unit. So let's do the action points plus the get action points, just like this. All right, so this function should be working. Now all we need to know is when to call this function. So first, obviously, we want to call it on start. So let's go there. So up here, we've got our start. So as usual, let's call it. Then we also need to update this when the selected unit changes. So let's go into our nice callback, and up here, create the buttons, do everything and so on. Okay. Then when the selected action changes, just changing the selected action doesn't cost anything, so we don't need that. However, we also do need to update when an action point has been spent. And now here we actually have two options. So we can either go into the unit script, and up here we could add an event for when an action point is spent. That would be one approach. However, if we did that, then we would need to handle the event cleanup when swapping out the selected unit. Basically, the issue would be, so over here we could subscribe to the on the selected unit changed, and then here we would subscribe to the event on the selected unit. But then whenever we change to another unit, we would need to unsubscribe that one and subscribe to the new one and so on. So it's definitely an approach, but it's a bit more complex. So let's go with a much simpler method. Let's just go into the unit action system. And on this one, let's just make another event. Let's make public event of type event handler. And for name, let's say on action started. So let's just fire this when we trigger an action. So let's go down. Let's find the handle selected action. Okay, here we take an action. And after we do, let's just invoke this event. Okay, that's it, super simple. So we just have this event whenever an action starts. Now on the UI, we can just listen to this one. So let's subscribe to that one. So this one is on action starting. Let's make the function to listen to this one. So let's go down here, make a private void with this name, with an object sender, event args empty. And over here, when an action has started, that means we've already spent the action point, so let's just update. Okay, that's it, super simple, let's test. So here we are, and yep, we can see this unit has 2 action points. Now if I do a move action, there's the busy, and yep, now only has 1 action point. And if I select this other unit, yep, this one has 2 action points. So I can move this one, move once, 1 action point, move again, 0. Then on this one, try doing a spin, can't do it, move again, and back to 0. All right, awesome. Okay, so here we implemented our simple action points mechanic. Our units now have a limited number of actions that they can take. The next obvious mechanic is some kind of reset, and we're going to do that when we end the current turn, so let's make a turn system in the next lecture.